All right, we are going to go over the 5-10 notes on polynomial functions and behavior. So as you guys know, I'm not there today, so hopefully everybody watches the video so we can catch on. This is activating strategy, asking you about, do you think a quadratic regression would provide a good model for this situation? So we have tried a couple times to calculate the quadratic regression in Desmos. And here's just saying, looking at these two graphs, what kind of shape do they describe, kind of as you're looking? If I go and kind of try to kind of connect the dots, right, they're not going to be perfect. This is what the function will look like if I try to connect the dots going this way. The function is much different. So looking at both functions, I would say in this situation, yes, because this looks like a quadratic function, right? It looks like a parabola. And here I would say no, because it looks a little bit different, and we're going to talk about it further, because this looks more like a cube function, okay? All right. So polynomial function is a function where the coefficients are all real numbers and the exponents on the variables are all whole numbers, okay? So looking at the first example, it's asking you to circle each example that is polynomial. Draw an X over each example that is not polynomial. So again, polynomial will be when the coefficient, which means the number in the front of the X, is a real number, okay? And then the exponent, which is the 4 in this particular example, it's a whole number. It means not a fraction, right? Or a square root or anything like that, okay? So it's asking us to circle each example of the polynomial. So this one will be a polynomial because, again, real number in the front and a whole number as exponent. 3t squared minus t cubed, it's also a polynomial function. Let's see. This is 0.75, so that would be a fraction. So that's not a polynomial. Okay. Here, let's see. This will be a polynomial because, again, 0.15 is a real number and 101 it's a whole number. Let's see. This one right here, 2z 12. Let's see. And 1/2 to a 7. 3 to the x is not going to be a polynomial. This will be an absolute value. Okay. This one will be to a 1/2. So I can convert this one to a 1/2, x to a 1/2 as an exponent, right? Because that's a square root. And this one as well, it's not, because that would have a negative exponent. Okay. All right. So here the degree of the polynomial with the only one variable is the largest exponent of that variable. The leading coefficient is a number written in front of the variable with the largest exponent. Polynomial should be written in a standard form. So what does that mean? Okay, and that means that we start with the highest degree first. So as you guys notice, we got quadratic, we got cubic, we got quadric, and we got quintic. Okay, so quadratic right here starts with a degree 2, and then it goes to 1, and then it goes to no x. Okay, a cubic starts with a degree 3, then it goes to degree 2, then it skips degree 1, and it goes to 3. Okay, here we go 4, 2, and then none. Here we go 5, 3, and 1. So sometimes we're going to be missing the degrees, but the bottom line is then when we putting it in the standard forms, it has to start with the highest degree first and then in descending order. Okay, so just always remember that the highest degree will start the equation, the highest exponent. Okay, so the number that is the biggest when it comes to the exponent of the x will start the equation. All right, so write the polynomials below in a standard form and state the degree and leading coefficient. So now, let's just review the leading coefficient, okay, means the number that leads the equation, that starts the equation, okay? But the equation has to be in a standard form, which means the highest exponent has to go first. So I got it at 6 here, at 3, none, and a 2, okay? Obviously, out of the 6, 3, and a 2, x to the 6 will go first. The next would be plus 4x cubed. Lastly, in the middle, sorry, plus 3x squared. And lastly, it's the one without the x, okay? So again, now this is a standard form. We started with a degree 6, went down to 3, went down to 2 in the descending order. Now, what is the leading coefficient? Leading coefficient is the number that is attached to the x in the front that starts the equation. And in this particular example, the leading coefficient is 1. So a leading coefficient is 1. So coefficient, oopsie, will equal 1, okay? And the degree starts with 6. Now the second example, all right, I got the 3, I got a 5, and I got a 1. Again, if nothing is written, that indicates that there is an x to the first power. So of course, negative 7 to x to the 5th comes first, because that's the biggest exponent of an x. Then we're going to add 0.5x cubed. And lastly, we're going to add 4x, okay? Now again, it goes from 5 to 3 to 1. And the leading coefficient here for this equation is going to be negative 7, okay? So leading coefficient is negative 7, okay? Because that's the number that starts the entire equation, all right? All right, so now we're going to talk about even and odd functions, okay? And degrees of those functions. So we got a bunch of equations here, and it's asking us, and again, I want you guys to take a minute to think about it, look at it. What do you notice about even and even degree, and then what do you notice about odd degree? Okay, so I'm going to explain it to you which ones. I'm just going to circle the ones that are even. Okay, so this is even. I'm going to put, oops, I'm going to put an E in here. This is even. This is even. This is even. And this is even. Okay. Because look, the degree it's x squared. Here I get x to the 4th. Here I get x to the 6th. And here I get x to the 8th. So all these numbers and those degrees are even. Okay. And this is odd. This is odd because that's 1. Okay. This is 3. This is 5. And this is 7. Okay. So these are all odd degrees. Now, what do you guys notice? Just take a minute. Pause the video if you need to. All right. So what I notice, and I'm hoping that you notice that as well, is that in an odd degree, the ends of the function go in the opposite direction. Kind of like when you're standing and your hands would go one up, one down, kind of in an odd way. Okay? Odd direction. They are going in opposites. Now, for the even degree, as you notice right here, both of the ends go in the same direction. Doesn't mean it gotta both going up. They're just going in the same direction. Sometimes they could also go down like this. Okay? So the main point here is that for the even function, ends of the function go in the same direction. Okay? And for the odd function, ends go in the opposite direction. Okay, so that's the main thing about even and odd degrees. And again, we are going to have to identify those characteristics moving forward, all right? And of course, you can also notice if you are given a function, which function starts, the leading coefficient and the leading exponent will be odd or even number. All right, so degrees and leading coefficients. What determines if the end behavior is the same or different on each side? And how can you tell if the right end behavior will go up or down? So what are we talking about? We're talking about these ends of the function right here, okay? Because remember, we always read the function from left to right. So if we always start this way, okay, we are talking about what determines the end behavior. So how is the function behaving? What is the function doing toward the end, right? No matter in which direction we're going here. Excuse me. There's the end. We start again from left to right. There's end. Well, and then how can you tell if the right end behavior will go up or down? Well, it has to do with the leading coefficient. So when you guys have functions that start, let's just say negative 3x to the fourth plus 2x plus 4, whatever. It's just I made up the function. So how do I know if the function, if the leading coefficient is positive or negative? Okay, it's if I am not given a function, if I look at the end of the tail, if it goes up, that means the leading number, let's just say 4x4 plus 2x is 4. If the function goes up, that tells me that the leading coefficient, which means the number that starts the equation, is positive. When the end goes down, that tells me that the leading coefficient, the number that is attached to the first x, the highest exponent of the x, is negative. Okay, so again, negative leading coefficient, this function might have started like this. Okay, so again, negative number right here. And then here again, a positive. So this function could have been 2x to the third plus 4x and so on. Does that make sense? So degree and leading coefficient, anytime the end of the function goes up, that means that the leading coefficient, the number that starts the equation, will be positive. And anytime the function's end goes down, that means the leading coefficient is negative. Okay? So let me erase this right here very quick. So I can write that out for you guys. So again, we said if n goes up, that's a positive leading coefficient. Okay? If the n goes down, that's a negative leading coefficient. Okay? All right. Moving forward. All right, so even and odd, what did you notice about the even and even degree? We noticed that both ends go in the same direction. Okay, so both ends, oopsie, both ends go in the same direction. Okay. And again, that's going to look like this. Okay. Or the other way around, going down. And what do we notice about the odd degrees? That ends go in opposite direction. So let's just say like this. Okay, so completely opposite direction. Now, what determines if the end behavior is the same or different on each side? Will be an odd or even degree. So the leading exponent, okay, depending if it has an odd number or even, will determine. So, even numbers would determine an even degree. That means both of the ends will go in the same direction. And an odd exponent that leads the equation will determine an odd degree, okay? Which means it will go in opposite directions, all right? And how can you tell if the right end behavior will go up or down? Again, right end behavior, we talk about the end of the functions. That would be your leading coefficient, right? So if your leading coefficient, meaning the number right here, that leads the equation, okay, it's negative, that means the end will go down. If the leading coefficient is positive, that means the end will go up. So again, you will have a function that's going to go for the positive, you're going to go function this way, okay? And for a negative, the function will end up going that way, okay? So this end right here tells me if the leading number is positive or negative, okay? All right, let's make that bigger very quick. All right, now degrees and leading coefficients. Here we got an even degree, and we have a positive leading coefficient. So what that means this end is going up, okay? Now here we got the negative leading coefficient. It means the end is going down, all right? So now here we're talking about end behavior, all right? Which means what happens, again, your favorite, what happens when we on the right side or the left side, okay, of the function. All right, so again, positive infinity and negative infinity, okay? So let's talk about it. Positive infinity and negative infinity, okay? So when we going toward positive infinity, means to the right, when we going toward positive infinity, where is my function going? It's going up, okay? Now the funny thing is that when we talk about the even degree, the ends go in the same direction. So if the right side goes up, so does the left side, okay? If you want to prove it, again, as we're going to the left toward the negative infinity, where's my function traveling? Again, it's going up, okay? Now for negative coefficients, even though it's going down, they both still, for even degree, are going to go in the same direction. So on the positive side, so right here, when I'm going from the middle, my function travels down, means toward negative infinity. And the same thing happens on the left side. When I go toward negative infinity, my function is still going down, which means toward negative infinity, okay? Now for odd degree, it's going to be the opposite, okay? So that means on the positive infinity side, on the right side, when I go to the right, my function looks like it's traveling up, okay? But now when I go on the opposite side, to the left toward negative infinity, as you can guys, I don't know what's happening. Okay, sorry about that. So again, as I'm traveling towards negative infinity here, my function is gonna negative infinity here. My function is going down. Okay, so again, it's the opposite. As you can guys see here, I got the positive, here I got the negative. Okay, because it's an odd function. The same thing is going to happen here. Just got to kind of read which one goes on which side. So again, on the positive side, positive infinity, my function travels down. I'm going to go down, which means this should go up. But let's check it. Going toward negative infinity, again, my function is going up. Okay? And then the last slide right here for you guys, it's asking you, let me see if I can make it smaller a little bit. All right, so We got the graph of the polynomial is shown, and which of the following statements is true. The degree of the polynomial is even. Okay, get a pencil here, and the degree of the polynomial is even. The degree of the polynomial is odd. The leading coefficient is positive or negative. Okay, and then we're going to talk about the end behavior. But again, remember, even it's when they go in the same direction. Odd, it's when they go in the opposite direction. Obviously, our two ends right here go in the opposite direction, so we know this degree is odd. Now, leading coefficient, it's either positive or negative. How do I know that? Again, I'm looking at this end right here, and I'm saying, is it going down or is it going up? Okay, this one's obviously going down, which means that's a negative. All right, so we are again going to choose D. Now, for the last piece right here, it's talking about the end behavior. Again, we have a positive side and a negative side of the functions when you look at the x. So we got a positive infinity here and a negative infinity here. If this is an odd function, that means these two ends are going to be opposites, right? So when I'm on the positive side, which is right here, okay, when I'm going toward the positive, my function is traveling down. So that means it's going to go down to a negative infinity. Now on the negative side, which is going toward the negative, my function is traveling up. So again, both of this one is up, this one is down. The two ends are opposite. All right. Now, what you guys gonna do here? Moving next. So finish. So your job today was to watch this video and fill in the notes so you can bring it and show it to me. So when you guys finish with the notes and everything, there is an activity that I have printed for you. You can work with a partner, or you can work by yourself. So that's part of that activity for you to finish up. So you're doing the notes and filling them in by watching a video and then working on this activity. Again, this is for me to see and turn it in tomorrow morning when you guys come back in, okay? Now, if you finish all of it, you need to work on missing assignments, delta math, factoring practice, whatever it is that you're missing, okay? Have a great day, guys.